Hey guys, welcome to another tutorial of the basic maths problem series. So this is after a long time. So just to give an context, so before we have started with the basic coding questions, basic mathematical coding questions, which will build your logic build your logic, and it will make you better with the problems with building the logics. Okay. So previously we have done few questions. Now today we have a new questions, and for that I'll like you guys to take you to another website from where I have got these questions. So it says we have to reverse digits of a number. Let's say you will be given an integer n, return the reverse of the given number. Okay, so there is a small note also. If a number has trailing zeros, then its reverse will not include them. For example, reverse of 10400 will be 401 instead of 00401. So this is our problem. There is a slight catch in the note section, as you can see. Okay, so this is a very famous website, Take You Forward. Here you will get a lot of coding questions from beginner to intermediate to advanced level. Okay. Okay, let's me go back to our notes. So yeah, so this is the problem I have also written. It says given an integer n, return the reverse of the given number. If a number has trailing zeros, then reverse will not include those. Okay. So first of all, let me let us understand the problem first. Okay. Let's say we have an integer number. Let's say 123. So this is our number. Now what it says is we have to reverse the number. So what is the reverse of 123? It will be 3 to 1. Okay. How do we get this 3 to 1? And on top of that, let's say we if we have a number 12300, if you reverse this number, it will be like 00321, right? But here it says it will not include this double zero, it will just be 3 to 1. It will just be 3 to 1. Okay, so how do we get the logic of reversing the number? That's the most important part. Okay, so here what we need to understand first is how this 123 number got built. Like how we have this decimal numbers, right? So how do we get this 123 number? How we get is, let's say, uh, 0, 1, 2, and 3 into 10 to the power 0, 2 into 10 to the power 1, and 1 into 10 to the power square. So this we have 100, here we get 20 plus 1 equals to we get 1 to 1. So this is how this number is actually got generated. So we have 3-digit number. So for the first digit we have to multiply into 10, and in the square will be 0 because the power is starting from 0. So we have 0. In the second position, we again multiply it by 10, and in the power we have 1 because 0, 1, 2. This is how the power gets increased. And in the third position, we have 1 because the digit is 1, 1 into 10 square. So we get 100, 20, and we add it and we get 1 to 1. So this is how the number gets generated. Okay. Similarly, if we want to get the digit of a number, let's say in 1 to 1, if we want to get the digits, what we have to do? We have to divide it by 10. 10, if we divide, we get 21. Again, we divide by 2, we get 1. So this is called remainder. This is called quotient. This is called dividend. and this is called divisor. We know this basic maths, right? If you don't know, then this is the best time to know. So these are the four components of a division when we do a basic division. So if you see the remainder, if we divide 1 to 1 by 10, the remainder is 1. Okay. Again, if we have the quotient 12, if we divide 12 by 10, we get the remainder 2. Again, if we divide 10 by 2, we get the remainder as 1 because 10 will not be able to divide 2, so we will get 1. So this is how we get the digits. Each digit if we divide it by 10, we'll get the remainder as the digits. In this case, we have to get the reverse. Let's say if we have 1, 2, 3, and if we divide it by 10, we get 23. If we divide by 2, we get 20, and this is the 3, which is the remainder we get. Now, if we somehow can get the remainder to the first, in this case, which is 2, then again, if we divide 12 by 10, we get 2, and if we get the 2 here, we get 1, and if we divide 10 by 1, we'll get the 1. So, if we somehow can create a logic which will give us the remainder, basically which will give us the remainders from the starting, we'll get the reverse of the number, right? So how do we do that? So for that we can apply a logic. Let's say we get the remainder 3 in the beginning. If we can multiply it into 10, plus, if we let's say if we take an integer number, and if we start it from 0, and then we add the 0 here, we get 30, right? Then we get 2, and in 10, plus after this the remainder will be whatever the number we are getting. So in the first case it was 0, but after that the remainder was 3, right? So if we add the 3, we get 23, right? So this is where we will be getting the this is how we'll be building the logic to get the numbers. Okay, so in the first case we get 30. Then if we can store the 30 in a number, let's say integer number equals to whatever we get here. So we get 30, and if we can multiply that 30 into 10, plus whatever remainder we get. So the first case we got 0. So now let's get back to the problem what we were discussing. So if we can somehow, let's say, get the remainder of a number, let's say we have 3 to 1, right? How do we get the remainder? We'll be dividing by 10, and then whatever at the end will be remaining, we'll get the remainder, right? In this case, it's 3. Then if we again divide 32 by 10, we'll get 2 as the remainder, right? So the thing is, if we can get the remainder which we can get from dividing it by 10, how to do that in maths, or how to do that in coding, with that we'll see. But this is how we get the remainders, right? Okay, now we know how to get the remainder. If we can initialize one, let's say uh, number with 0, with a reverse number by 0, and if we can get the remainder equals to whatever number we have modulus 10, we will get the remainder. This is how we get the remainder. And then whatever number we have initialized the revised number is, if we can somehow write a logic like reverse into 10 plus remainder, what we will get is, in this case our remainder is, what is our last remainder? Our last remainder is 1. So what we will be getting is, remainder we will get as 1. Then in the reverse we will get reverse into 10, this will be 0 plus 1. So remainder will be, reverse will be 1. In the next, again if we do the same thing, which is 32, 32 the remainder is 2. So here it will be 2. Then the reverse will be uh, 1 into 10, because it's now 1. 1 into 10, which is 10 plus 2. 10 plus 2, which is 12. Okay, so we get 12. Again, if we divide 10 by 3, which will be the remainder will be 3. In this case, it will be 3. So in this case, now it is 12. 12 plus into 10, 120 plus 3. So 123. So the number was 3 to 1. Now the reverse is 123. Okay. Okay. Let me do this thing again in a proper way. Now with a loop. So we got the problem. So what we need to do? Let us create a method. Let's say in Java, uh, reverse the number. We take an input as number. So first we need to initialize one number and we are naming it as reverse with 0. We have initialized this with 0. Now we need to write a loop. Number greater than 0. So till the time number is greater than 0, this loop will keep on working. Now what we'll have to do, we need to get one remainder. How we get the remainder? Number modulus 10. This is how we get the remainder, right? So here we get the remainder. Then now the main logic. So how we'll get the reverse number is, let's say we have already initialized reverse with 0. So now what we'll do, reverse equal to reverse into 10 plus this remainder, whatever remainder we are getting. Okay. And then after that, we have to divide num by 10, because each time num is divided by 10, and at the end of the day, let's say instead of void, we'll be returning integer, and here we'll be return rev. So this will give us the reverse number. Okay, try it yourself. This is the main logic what we need to do to get the reverse number. Other than that, this is how we get the digit of a number. Okay, so this is the main logic. This is how we get a reverse of a number.